Welcome to finding the tangent line at a point. So the idea here is we've seen before, so recall that the instantaneous rate of change could be found from taking a bunch of secant lines and then letting the points get closer and closer together. So we had our picture of whatever is going on. And we have our point at C. And then we could take a whole series of points and let those points get closer and closer in. And ultimately, we will wind up getting a line which seems to just barely skim the graph. And so the line that these secant lines approach was called the tangent line. So the line the secant lines approach is the tangent line. I'm going to give myself a little more room here. So the line that the secant lines approach is considered to be the tangent line at x equals c. And the key features of the tangent line be first up, just by definition, remember the instantaneous rate of change is the slope of that line, and that is precisely the derivative. So first up, the slope is simply equal to the derivative at c, so f prime of c. And it passes through the point at x equals c, so it passes through the point c, f of c. So if we know c, f of c, and the derivative at x equals c, we can then find the equation of the tangent line. So let's go ahead and consider the function f of x is equal to 2x squared plus 1. And then our job is to find the equation for the line, which is tangent to the graph of f of x at the point x equals 2. So essentially, again, we are looking to the tangent line at x equals 2. So we already saw that this line should have slope equaling the f prime of c, so in this case f prime of 2, and it will pass through the point c f of c, so in this case 2 f of 2. So we know that we have slope will be equal to f prime of 2. And then we also know that we have the point, we have the point 2 f of 2. So the slope will take a little bit of time. The point is pretty quick, right? So the point, we have 2, and then f of 2, we're looking at 2 times 2 squared plus 1, or the point 2, comma 9. Our slope, we are looking for f prime of 2. So we know that we are looking for the limit as h goes to 0 of, we'll do an f of something plus h minus f of something all over h. Again, we're looking for f prime of 2, so we fill in those blanks with 2. So we are looking for the limit as h goes to 0 of f of 2 plus h minus f of 2 all over h. And this will find the slope for us. Once again, we need to find f of 2 plus h, and we need to know f of 2. We already found f of 2 on the side. F of 2 was equal to 9. So just a f of, oops, sorry about that. Right. So this f of 2 here is precisely what we did over here. So we got 9 for f of 2. F of 2 plus h, we still need to figure out. So f of 2 plus h, we have 2 times 2 plus h, quantity squared, plus 1. This becomes 2 times 4 plus 4h plus h squared plus 1, or 8 plus 8h plus 2h squared plus 1. If we rearrange that, we have 2h squared plus 8h plus 9. At this point, we can go ahead and finish calculating our slope. So we know that our slope is equal to the limit as h goes to 0 of, we have 2h squared plus 8h plus 9. Then we will subtract off 9 and divide by h. So once again, this 2h squared plus 8h plus 9 was our f of 2 plus h. And that 9 was our f of 2. Simplifying this, we wind up getting the limit as h goes to 0 of, we have 2h squared plus 8h up top, divided by h. This will be a 0 over 0 scenario, so we will simplify. We wind up with a limit as h goes to 0. We could pull out a 2h, but really the only thing we care about is the h. So we'll go ahead and just pull out an h, leave inside 2h plus 8, dividing by h. The h we factored out cancels with the h from the denominator. And then as we let h go to 0, we can just plug in And we are simply left with 8. So we have a slope of 8. And then we also have our point 2, 9. At this point, we can do our equation of a line. So the equation of the tangent line you can either do y equals mx plus b format right off the bat and just solve for b, or we can do point slope format and rearrange. Ultimately, you will, at least on your homework, you will need to put your answers into slope intercept form. So if we did point slope form and then rearranged, again, point slope form, you do y minus whatever our y value is, minus or equals the slope times x minus whatever the x value is. So we'll do y minus 9 is equal to 8 times x minus 2, and then we can rearrange if necessary, right? So this is the same thing as y minus 9 equals 8x minus 16. And then if we added 9 to both sides, we wind up with y equals 8x minus 7. So both of these are equations of the tangent line. The top one, again, is what we call point slope format. And the bottom one is what we call slope intercept form. Right, so this is finding the tangent line. You really just need to find the derivative at the point and the function value at that point. And then you can build the equation for the tangent line.